So if we have a problem where we're giving all three sides of a triangle and no angles, we can still use the law of cosines, we just have to rearrange it a little bit. So what we're gonna do is we're gonna take this, just the normal old law of cosines, and we're gonna rearrange it or solve it for this cosine of A. So to do that is just algebra stuff. We want to get this by itself, subtract b squared, subtract c squared, and then you're going to divide everything by negative 2bc. I won't bore you with the details, but here's what happens. Once you do that, you get that the cosine of angle A equals b squared plus c squared minus a squared over 2 times b times c. So I have angle version written in quotes here because that's not really what it's called, it's just what I call it. So the first thing we saw is the side version because we use it for getting sides. If we don't have any angles, we just have a bunch of sides, then we have to use this version. So it's not a different thing, it's just a rearranged version of that. Okay, so here's where we would need that example. The instructions for all these are just solve the triangle, so that's kind of why I haven't been writing the instructions, because they're all the same. So let's say that's 40, that's 12, and that's 44. We haven't seen this yet. We don't have any angles. If I gave you a triangle with all three angles and no sides, you couldn't solve that because you wouldn't know how big it was. Okay. So the first thing is, let's just label it, right? It's unlabeled. We can call it whatever we want. Let's just follow my convention of just starting at the bottom right corner and going around like this. So that's angle A, that's angle B, and that's angle C. Which means that's side A, that's side B, and that's side C now. If you labeled it differently, it wouldn't be wrong. You just have to be careful and use the formula right. Okay, so let's fire it up. So the cosine of angle A equals, so it's the squares of the other two sides. So it's 44 squared plus 40 squared minus the square of the corresponding side over 2 times the other two sides. So 2 times 44 times 40. Okay, so just like with the other version of the law of cosines, it's just a big formula, and formulas are hard to use. You have the numbers in front of you. The thing that messes people up here is punching this step into your calculator wrong. So if you were just to start typing like left to right and type 44 squared plus 40 squared minus 12 squared over 2 times 44 times 40, what would your calculator interpret that as? It wouldn't know that you meant all this over all this, right? It would think that you meant just this divided by 2, and then it would multiply it by 44, and then it would multiply it by 40, right? So all your calculator knows is order of operations and to go from left to right and just do whatever you tell it. You have to know that if you want to type this in all at once, this better be in parentheses, so I'll just put parentheses around the numerator and I'll put parentheses around the denominator. Right? It needs to know that you mean to take this entire number up top and divide it by this entire number on the bottom. Now, you can just compute this as one thing and then compute this as another thing and then write that out in the next step and then do the division. Fine, right? But there's not a lot of real work to show here because your calculator is doing all of the work. Okay. So type that in carefully. You're going to get something along the lines of 0.9636 repeating. I'm sorry, 9636 36, and just that part's repeating, so it's 0.96363636, blah, blah, blah. And then remember, that's not the answer. This is the cosine of angle A. So you have one more move. Angle A is arc cosine of this, but again, you're not going to type this. You're just going to use ants. You're just going to do arc cos of ants. So that's 0.9636 repeating. And then, you get what you get. You get A is about 15.5 degrees. All right, so if you jumped right from here to the answer, this is one case in math when, that would be fine. That's how I would do it. I would do this all on my calculator. So there's really not a lot of work to show. If you're going to show any work at all, you would just maybe write, okay, this is what this numerator is and what this denominator is. You could write this decimal, and then you could write the arc cosine. So you don't have to even write as much as I'm writing here. You just have to be accurate, so just be careful. Okay, so we have all three sides. We have one angle. Now we have this angle, which is a small angle. It's 15.5. Cool. Now we have two choices. We could do what we did in the last problem, because now if you're noticing, oh hey, I now have an angle and its corresponding side. So that should cue you to oh, now I can use the law of sines to finish this whole problem. Or you could literally just do this again. You could do this again, just do it with angle B instead. Just crunch all these numbers just for angle B instead, and you get this. I personally think this is easier to use because there's less algebra, there's more just punching numbers in. Your call. I wouldn't tell you which way to do it. So now I will illustrate these two possibilities, and then I'll just leave it to you to finish it up. So using the law of sines, you'd say sine of 15.5 over 12 equals, it wouldn't matter which angle you got now, just do B, put it on the alphabet, equals sine of B over 40 Now it's literally exactly the same as the last problem we did. You just multiply both sides by 40. You do sine of B equals 40 times this. You do an arc sine on that and get what you get. Or I will say using cosines again. We have all three sides already, so we don't want to use the sides version of cosine because that's for when we need a sine. What I mean is we can just literally do this exact same thing again with a different angle. So if you're going to do that, you would get cosine of B equals, so it's the other two sides first, so it's 12 squared plus 44 squared. You don't have to memorize this formula, so don't worry about remembering which side it is, really. So I do. Minus the corresponding side over 2 times the other two sides. So 2 times 12 times 44. So just be careful applying this. I see mistakes like people forget to square these top ones, or again, just punch it into a calculator lazily. If you're being accurate here, this is a pretty easy formula to use. All right, so I don't feel the need to do it because it's exactly the same as the last one. You're just going to get cosine of B equals some decimal. You're going to do an arc cosine on that decimal, and you're going to get that angle B is about 62.96 degrees. Which, not a perfect picture, but looks like it could be better. Okay, and then angle C is the big one. But again, we're back to the same position where, okay, let me circle what we've actually done here. We had all sides, we got one angle, and then we had two possible routes to choose to get to the second angle. Now, could you do this again with angle C? Sure, if you just like doing math. Could you use the law of sines to get angle C? Sure, or don't. Just anytime you have two angles, right, you have the third one basically for free. So just remember that angle C is 180 minus this minus this. Just punch that into your calculator and you get to the 100 something. So never use the law of cosines or law of sines to find the third angle when you can just use the 180 thing. I mean, you can, it's not wrong, it's just too much. Okay, so that's everything you're going to encounter. Right, that's really every possibility for oblique triangles except something called the ambiguous case, which I'm skipping. So all we have to talk about for this section really is just applications, just story problems doing navigation and astronomy and that kind of thing, except now we can do it on any triangle, not just right triangles. Thank you.